Right? And then finally, the last one, we have to do some trig stuff. All right, so this one's gonna be a little ugly, but you know what? Math doesn't always have to be so super pretty. Right, so we know that our value of a is zero, so a is zero. So then now I'm gonna take the sinh, so f of zero is equal to the sinh of the cosh of zero. Cosh of zero is the same as like the cosine of zero. It's going to equal one. So it's going to equal the sinh of one, which I'm going to leave as an exact value, right? If we really wanted to calculate what the sinh of one was equal to, we'd have to go back to the exponential definition of it, right? So it'd be e to the first power minus e to the negative first power over two, right? So if you're doing like technology or something, you may see it in some form like that as an answer. But I'm going to leave it as sinh of one. All right, so next thing we need is a derivative. All right, so I'm taking the sinh of the cosine. Right, so again, I'm going to do these ones a little bit faster. Right, derivative of the sinh of anything is going to be the cosh of that anything times the derivative of what we're taking the sinh of, aka derivative of what's inside. So I'm going to get the derivative of the inside, which is going to be a sinh of x, times the derivative of sinh, which is cosh, and then I'm not going to change whatever's on the inside, so cosh of x is our derivative. When I figure what this is at zero, I'm going to get the sinh of zero, which is going to be nice because that's going to be zero, times the cosh of zero. And so since sinh of zero, like sine of zero, is equal to zero, our derivative is going to be zero. So when I throw this into Taylor form of a line, we're going to get another nice easy derivative because of the zeros here. Right, so f of a we found was the sinh of 1 plus 0 times x minus 0. So our tangent line is just going to be the value of the sinh of 1, or if we were being, fancy again, e to the first power minus e to the negative first power over 2. And if we were being really, really fancy, we can say this is e minus 1 over e over 2. We can get some like terms in the denominators, right? E squared over e, so e squared minus 1 over 2e, like that would be the derivative of the tangent line. And then just because why stop the video so early? Let's check this, right? So if we graphed f of x equals the sinh of the cosh, right? So I got y equals the sinh, which we can plug in, of the cosh. We're gonna get some function looks like that. If I want to find the tangent line, we found that it was y equals just the sinh of 1. Right, and there's our tangent line, just like we would expect. And this value right there is obviously e squared minus 1 over 2e.